Which came first, the chicken or the egg? This classical dilemma has stumped armchair philosophers for centuries. Although if we're considering a broader interpretation of what an egg can be, then it certainly came before the species of the modern chicken. At the core of this question is the issue of interdependence. Both the chicken and the egg are dependent on one another. A similar question has arisen in the philosophy of mathematics. Which came first, mathematics or experience? When examining a scientific equation, such as the ideal gas law PV equals nRT, questions arise as to how we as humans have come to such a discovery. At first glance, it seems as if this law is forcing gas molecules to behave in a specific way, as though there is some abstract mathematical realm which holds power over how the physical world operates. This view of mathematics is called mathematical Platonism, named because it was first popularized by Plato and his realm of the ideal. To Plato, there existed a realm separate from the physical universe in which the perfect forms of all objects resided. The form of man, the form of chair, the form of a tree, and so on. Along with this were the forms of numbers, geometry, and other mathematical objects. You see, Plato believed that the only way of gaining absolute knowledge was by somehow accessing this realm with the mind. To him, experiential knowledge is inherently flawed, since all objects change with time. Yet, we seem to have perfect knowledge about mathematics, and mathematics doesn't change with time, so the natural conclusion is that mathematical objects must exist in the realm of the ideal. This argument is certainly valid, but it doesn't necessarily hold up to Occam's razor, the philosophical notion that the argument making the least number of assumptions is probably the best, since it postulates the existence of a realm of which we have no proof of. There are more specific subtheories of Platonism, most notably logicism and the mathematical universe hypothesis. Logicists believe that mathematical objects and mathematical truths are really logical objects, deduced from a single set of self-consistent axioms which govern all the processes of the universe. From their point of view, it is logic and the necessary truths we have given to it which should be prioritized. It is logic and these truths which exist in the realm of the ideal, and through this logic we gain analytic truths or statements which are true by definition about mathematics. Famous academics who fall into this category include Gottlob Frege from the Introduction of Naive Set Theory video, and Rudolf Carnap, a philosopher of language. The mathematical universe hypothesis, popularized by the MIT cosmologist Max Tegmark, asserts that mathematics not only exists, but is the only thing that exists. In this philosophy, every object we experience is actually mathematical. Indeed, we ourselves are mathematical, and the processes of gaining knowledge about math is mathematical as well. In other words, the Platonic realm of mathematical ideals is identical to the universe and our experience of it. They are one and the same object. In opposition to Platonism, one might conclude that humans develop mathematics from observations about the universe. With respect to the ideal gas law, it's possible that gas simply acts in an orderly manner on its own accord, and we measured and quantified what this process was, applying numbers and labels which don't exist separate from the gas itself. The umbrella term for this philosophy of mathematics is nominalism, the idea that mathematical objects exist in name alone. Within nominalism, there are many subtheories as to what the mathematical process actually involves. Formalism is the philosophy that mathematics is entirely derivable by formal symbolic theories or logics. This may sound very similar to logicism, but formalists do not believe in a single batch of logical truths. Instead, logical truths are completely arbitrary and can be changed depending on who is actually doing the mathematics. And as such, they do not assert a separate, foundational existence in a separate realm to any of the theorems they derive, instead believing that all of mathematics is simply symbolic manipulation using deductive rules which allows mathematicians to come across new sentences. Two mathematical theories being inconsistent with one another is no issue to them. It simply means that there are multiple ways of doing mathematics. This view is popular among mathematical logicians, especially model theorists, and it was popularized by David Hilbert and Alfred Tarski. Intuitionism, also sometimes called constructivism, was put forth by the Dutch mathematician L.E.J. Brouwer, who stated that there are no non-experienced mathematical truths. According to this philosophy, simply defining a set of axioms and rules of deduction shown to be consistent does not imply the truth of all mathematical statements possibly derivable in that system. Intuitionists assert that a proof of the statement has to be formally written down before it can be assigned truth. In other words, theorems that have not yet been proven are not considered either true or false. This is known as a rejection of the law of the excluded middle, which states that any statement is either true or false. Brouwer borrowed largely from the transcendental idealism of the philosopher Immanuel Kant, who believed that mathematical truths were essentially hardwired into the construction of our mind and the way that we perceive the world around us. In other words, mathematics does not exist in the Platonic realm, but it actually exists in the makeup of our brain and its perception of reality. Last but not least, we may briefly consider my own philosophy of mathematics, which doesn't really fit well into any category. I consider myself a mathematical monist, meaning that I assert the existence of only a single mathematical object, that object being the number 1. Since I am an ontological monist, meaning that I only think one object exists in the sense of ontological independence, the natural conclusion is that this object must actually be the number 1, since it obviously has the property of being one object. In this sense, you could consider me a Platonist in the mathematical universe camp, but really only for the number 1. Alternatively, when it comes to what most people call mathematics, I fall more loosely into a mix of Kant's transcendental idealism and formalism. I believe that symbols are hardwired into the human mind's perception of reality, and from these we utilize symbolic manipulation to develop a collection of logical theories that assert a multitude of statements which we collectively call mathematics. Ultimately, however, there is no clear way of determining what mathematics actually is, and because of this, philosophers will have to continue to debate and ask these questions. So let me know what you think. Is pi really in the sky? Stay curious.